Okay, so hello, class. So yesterday we did half of the practice questions. Today we'll do the other half. There is one question that is still a little confusing to me that I'm going to skip over, but the other four we'll be able to go through. So yeah, let's get right into it. Okay. So if you have the website open, you can go ahead and just skip to question 7, or excuse me, question 6 here. Is everyone there?
Yes.
Yes.
All right. I need a volunteer from the audience. How about you, Patsy? Would you mind reading out the question?
Okay. Let's see. Well, you have it on 7, right? Is that one it? The one you have?
6. Number 6.
Okay. So 2 sides of a triangle have lengths of 10 and 17. If the length of the triangle extends to, sorry, your little arrows there, so I can't see what it says.
You need to move your mouse arrow.
Oh, sorry.
Thank you. Okay, let me check it. So if the strength of the triangle extends to the third side and has a length of 8, what is the length of the third side of the triangle? Okay, let me put on my glasses too.
Okay. So there's a couple of keywords here. The first one is triangle. And so that already throws into our mind, okay, this is a geometry and trigonometry problem, right?
Yes.
And beyond that, it's saying we need to find, it's talking about the different sides of a triangle. So the first thing, as always when dealing with these problems, is what is the question? Adeline, can you identify what the question is?
It's trying to know well, it wants to know the side of the triangle. So
just identify the part of the problem actually asking us a question.
Well, this is a trigonometry question. Wait, can you repeat your question again?
What's the actual question? There's a lot of words, but what is it actually asking us to do?
Well, it gave us it identified two sides of the triangle, so it wants to know what the other side is.
Okay, great. That's our question.
So we can draw a little triangle and just kind of put the sides, label the numbers there. Sorry, I was answering people's messages.
No worries, you're good. I know.
Back on now.
Oh no. It's just you and I, Scotty.
I know.
She's being represented over there.
I know.
That's good though. People want to join.
Length of the...
Well, we can call that like our X side and or third side.
Side of the triangle. Okay, what is the length of the third side of the triangle? All right, so the trick with this one is figuring out what the triangle looks like. Is it a triangle like this with sides 1, 2, 3? Is it a triangle like something like this with sides 1, 2, 3? So figuring out what this triangle looks like and figuring out which sides we know, that's what we have to figure before we can tell them what the length of the third side is. Because we have various relationships we can use to determine the sides of triangles, but we need to know a little bit more about what this one looks like. Does anyone have an idea what this triangle probably looks like?
Okay, so the I think it would be like the one on the bottom left, like 1, 2, 3. The one you have, that's like looks like a regular one. I forgot what it's called. It's not acute. Is it an acute triangle?
I think the acute triangle is the
Okay.
the
Let's
one
do a
with
quick
the-
little. Let's do a quick
Yeah, I'm
little
trying to
review here.
remember the names of the triangles first.
There's-
Let's start back there.
Okay. So for angles, so well, let's not worry about angles. There is a special kind of triangle called a right triangle. And what's special about a right triangle?
I don't know.
It's
I
90
can Google
degrees.
it.
It's either 180 or 90 degrees. Oh, I'm trying to remember.
Okay, Patsy, you're on the right track. So a right triangle has an angle that is equal to 90 degrees.
90 degrees. Okay, yes.
Ah. I put ripe triangle and I got fruit.
So
Okay, someone's hungry over there.
these sides right here, these sides are perfectly perpendicular. That means they're exactly 90 degrees from each other. And my virtual
Yes.
background is making my hand gestures difficult to see. But anyways, so that is one special triangle. And we will actually use this in determining the answer for this problem.
Okay.
But we're not there yet.
Oh, no.
This is something that's just going to be useful for us to have in our back pocket. Okay. So there is a little bit of information in the problem that tells us a hint about what this triangle looks like.
The height okay. The height of the triangle extends. So would that be the longer side extends to the third side and has a length of 8?
Right. So
I think so.
that sentence is the clue. The triangle. Let me go ahead and see if I
Yay,
can.
Patsy.
The height of the triangle extends to the third side and has a length of 8. Okay. That's enough to give us a hint, enough of a hint for us to construct this triangle. So it's saying that two sides of the triangle we know, and we don't know the third side, but the height extends into it. So that's telling us that the height goes
Up and down. Up and down.
right.
Okay.
So here we go. So you have a triangle like this. So we know, we have two sides like this, a short side and a long side. And
The height is in the middle. Yeah.
right, the height extends to that third side. So we can now we know what our triangle looks like. So we know the short side is 10 and the long side 17. And we know this height is 8.
Yay.
So now we know what the triangle looks like.
Got it.
And so we, I think Adelaide said to treat this as our x. So we'll go ahead and use that.
Sounds good.
This is what we're trying to find, right? X here.
Now we have to remember those formulas, right?
What kind of formulas? What formulas?
Well, A, I remember is A over height or something like that. Like area over height equals half. I'm trying to remember. It's been a while, but I know there's formulas to solve for x because you have all those numbers and you can plug in those numbers into that formula to get that x. You just have to remember that formula.
Okay, so let's
Sorry, I'm reading one of the somebody else joined.
Oh, okay. Hi there, Danny.
Hi.
All right, nice to meet you. We just started this question. We can give you a quick little intro into here. So we're just going over some of the questions from like a GRE prep test. So this question is a geometry question. Two sides of a triangle have lengths of 10 and 17. If the height of the triangle extends to the third side and has a length of 8, what is the length of the third side of the triangle? So what we're going through now is first we had to figure out what the triangle looked like. So I knew that there was one side that was length 10 and one side that was length 17. And we know that the height extends to the third side. Excuse me, yeah. And the height is has a length of 8. So we came up with this drawing here. So one side is length 10, one side is length 17, and then the height extends to the third side, which we don't know the value of. So the first thing we did actually was we isolated what the actual question was. With a lot of these GRE questions, there's a lot of words, and sometimes they kind of hide what it is you're actually trying to solve for, what they're asking you to do. So the first thing we do is we isolate what is the actual question, which is what is the length of the third side of the triangle? And so from that and the information they've given us, we came up with this drawing. So everyone with us so far? Everyone follow?
Yeah, that makes sense.
Okay, great.
I'm following now.
Okay,
Like I'm
great.
here.
So here we go. So who has an idea of how to find x here?
I'm trying to look up the formula, Scotty.
I know I
Is
forgot the
this-
formula too.
Is this the one where you do a squared plus b squared equals c squared? Is that not the right one?
Yes, I'm trying to
Okay,
remember.
what is that? What is that you just said? The a squared plus b squared equals c squared thing.
I honestly don't remember what it's called, but I remember the formula from like 10th grade.
Okay, you're on the right track. In fact, that's a pretty good idea. So here's what you're talking about. That's called the
Triangle. Well, no, never mind.
that's called the Pythagorean
Yeah.
Theorem. And what that's saying is, if you have a right triangle, then this relation is true. A squared plus b squared equals c squared. Okay. Can that help us here?
No, because this isn't a right triangle. It's obtuse.
Right. It's got really crazy angles everywhere. But
we have the height of that center right there, so we have two different triangles in essence.
We need to solve for each.
yes.
You
Right.
do both of them and subtract.
Mm-hmm.
Right.
Yeah.
So I'm going to draw this a little bit bigger. So what we have here, because the height is bisecting this triangle like this, we can treat this as two separate right triangles.
Got it.
So they both have one side length of 8. We have one side length 10 and one side length here 17. So on a right triangle, this side here, what's the name for that?
Not the length. The length.
Which side?
The hypotenuse.
Hypotenuse.
Right.
That's 17, isn't it?
Right. Anyways, so what we can do is we can treat this as two different right triangles. So let's call this one, we're using x for this. So let's call these, A for, call this bit here A, and this bit here B. Okay. So we've got one triangle, which is this here, and a second triangle with this. So if let's take the first triangle, the triangle with A on it. If we tried to write out the Pythagorean theorem, what would that look like?
Going to be 10 squared. So you have, yeah, so 10 squared plus 17 squared plus, oh, no.
We're just gonna look at this one for, let's see. Oh, yeah, I'll split them up into two separate triangles. So let's look at the first triangle. Oop.
I think it's gonna look like the question I just typed in the chat.
Okay. 8 squared plus b squared equals 17 squared. Okay, well, that's the second triangle. We're looking at the first one with A on it.
Oh, sorry.
Okay, so if we have this triangle, what's our Pythagorean theorem going to look like? You're right for the second triangle, Adelaide, but
Would it be 8 squared plus b squared equals 10 squared?
say that again.
So 8 squared plus b squared equals 10 squared?
8 squared plus, you said b?
Uh-huh. So would that
Well,
be
we're looking at this
no,
triangle here, right?
calculating the sides confused. So that would be C.
Okay, Adelaide, you've got it. Patsy, you were right. You were right. You
Yeah,
moved the
I
letters
swapped
right.
my letter, sorry.
Right. Adelaide's got it here. You're both right. You just got your letters mixed up. So it's a squared plus 8 squared equals.
It's just her accent, Scotty. She did say 8.
No, it was
Thank
B.
you, Adeli.
She said B instead of A.
I think she said 8.
Okay.
It's okay, move on.
All right. Anyways, so yes, so we have this. Does everyone see how we got that? Anyone not see how that worked out? How we got to that?
I think I'm good.
I'm just gonna make a little separation here. Okay. Okay. So when we have a variable equation like this, what do? If we want to try and figure out what A is, what do we do with all the numbers?
We need to get them to the same side. So minus 8 squared.
Perfect. Right, so we're gonna subtract 8 squared from both sides. So we have A squared equals 10 squared minus 8 squared. So what's 10 squared? 10 times 10?
100.
There we go. And what's 8 squared? 8 times 8?
64.
Yep. There you go. All right. Cool. What do we get?
36.
There we go. All right. So if we want to get A, remember this is A squared. How do we get rid of the square?
You square root it. So
Yep.
the answer is 6.
Perfect. All right. There we go. So we've got half of our answer now, right? Fantastic. We just need to do this one more time, right? So let's look at our other triangle. This is a perfectly drawn triangle, nothing kooky about that. Okay, so we're going to do the same thing. And I think Adelaide's already gone ahead and written out what this one looks like. So in the chat, so here we go. B squared plus 8 squared equals 17 squared, right? So we're going to do the exact same thing. We're going to subtract 8 squared from both sides. And we want to find out what 17 squared is?
289.
289?
Correct.
Okay. Minus 64. I'm terrible at math, so someone else do the arithmetic for me, please. What do we get? 225, right?
Yes, 225.
Okay.
Good job.
All right. So, and now we, again, remember, we're done, right? Right?
No.
Right?
No.
Okay.
You need to do the power, the exponent. You need to
Right.
simplify that.
Right. We need to get rid of this guy, right? So if we square root it, what's square root of 225?
15.
Woo! Okay. So that's great. Now we go back to our original problem. We're trying to find x. X equals a plus b, right?
Mm-hmm.
X equals 6 plus 15. X equals 21. And there it is. It's C, of course. It's always C, right?
I wish it was that simple, Scotty. Not always easy.
All right, fantastic. Does anyone have any questions about how we did this?
I just need to review because if it wasn't for Daniela saying the AB squared plus A squared plus B squared plus equals C squared, I probably would have been lost.
We need to make a little cheat sheet with all
Okay.
the formulas.
All right. I'm going to tell you right here, spoiler warning, you're going to get questions on the GRE where you're going to have to deal with right triangles. You're going to have to use the Pythagorean theorem. You're going to have to know how to split triangles up. This is a really great example question because you're going to see at least one of these. Guaranteed. Absolutely. So if anything about this question didn't make sense, try it again on your own until you're good at being able to solve this one. And then another thing I did want to mention, a lot of times on GRE questions, if you're on the right track about a solution, the math is generally going to work out to be really nice and elegant. So if you noticed on these, I'm going to grab green here. When we got to the square rooting part for A and B, it's like, oh, hey, this just happens to be a really, a number that, is a square number, it just happens to be a really nice square. Same with this. Oh, 225, that's big. Oh, but yeah, it actually, it's just, it just turns out to be 15. That's not on accident. That's how those questions were designed. They're designed to come out and look nice and elegant if you're doing the math correctly. So that's kind of a hint. If you wind up doing the math and you start seeing numbers that look really ugly, you might want to take a step back and just look and see, am I doing this right?
That's a good hint, because I normally would get some funky looking answers in my exams, and I would just guess, because the numbers would be way too complicated to do the math for.
It is true though, with math, it's like it needs to flow. And if you miss a step, like you'll notice, because that's how math is. If you miss a step, it's all going to be wrong.
Right. Now, in the real world, you know, if you're doing math stuff in the real world, you will get, you know, questions and answers where the answer is some, you know, 8 decimal places long or something like that. But for mathematics tests like this, there's generally going to be really nice, succinct, elegant answers for them. That's going to be your hint that you're on the right track for something. And you can even see in the answers to this question, you know, there's no crazy decimal points here. There's no fractions or anything. Everything is a whole number. So you know whatever answer you come up with, if you have decimal points in your answers for things, it's, you know, probably on the wrong track. So yeah, just a little hint as things for the GRE. Again, remember that the GRE is not just about can you do the math, it's can you do it, can you first of all figure out what you need to do, and can you figure that out quickly? Because, you know, we're taking our time here. We're going through, we're reviewing, we're relearning all these things that we kind of forgot from high school and things. On the actual GRE test, they're going to give you about 1.5 minutes to do these problems.
No.
So yeah, the idea is look at it, read it, figure out what the question is, and then determine what information they've given you and what tools you can pull out of your head quickly to solve the question. All right, everyone feeling good?
Yes, thank you, Scotty.
All right, I'm going to go ahead and save this. All right, and I'm going to make up a new question. I think the next one is the one that we're going to skip over. No, the next one is 7. So there is one I'm going to skip over just because I'm not too sure on it. I answered and got the right answer, but it's like I can't explain it in a way that I can tell the other people, really, because it's like a weird relations question. So there's one question we're going to skip over. All right, we said this one. What did we say this one was? 21? Yeah, okay. There we go. Okay. So this one, we're going to do this one. So who wants to volunteer to read the question?
I can do it.
Okay, and I'm just going to push this down towards the bottom of the screen just because I know that on the video column, well, on the recording, the video column will overlap this. So, okay. So go ahead.
Okay, so for all numbers n equals 24 minus n. Compare the quantities in A and B and select the appropriate answer. Quantity A times, I think it's times n. Quantity B n. Well, equals to n.
Okay. So this is okay, so that's the reading of it. What is the actual question? You know, first thing we're doing, what's the actual question?
I believe it wants us to know, in essence, what the value of A and B is in order to determine which one's greater, or if they're equal.
Okay, can you say it again? You said determine what the values of A and B are. Is that what you said?
Not concretely, like not as a number, but more of a concept.
Right. You said figure out which one is greater, right?
Yes.
Okay. So that's pretty close what they're wanting us to do. What they're saying is, in this question, there actually isn't a concrete question. It's saying look at quantities A and B, and then pick one of these answers that describes them best. Quantity A is greater, quantity B is greater, the two quantities are equal, and the relationship cannot be determined from the information given. Okay, so with this one, the question is really a little tricky. Do we have a new person in the? Oh, we have a couple new people in the segment.
Hello.
Hey there.
Hey there.
All right. Okay, yeah, welcome. We're just starting a new question. So we just started reading this one, question 7.
Perfect.
So for all numbers n and dot n equal 24 minus n, compare the quantities in A and B and select the appropriate answer. Quantity A, dot n, or quantity B, n. So what we were first trying to do is we were just trying to figure out what the question is asking us. And really, from the basic text here, it's not actually asking a question at all. It's saying, it's basically just saying, compare quantity A and quantity B, and then describe it. The answer is just describing which statement is true. Which statement describes them the best. So really, our question. Oh, what's up?
Can I jump in? What's the dot n? Is that just like having a different variable?
We're going to talk about that in a second. What is that? So yeah, let's. So our question is probably the best way we can really say it is compare A and B, and pick the best description of them. Whenever we do these GRE questions, figuring out what they're even asking you to do is the first part, always. Because like this one, it's not even concrete, right? So first of all, and this is saying for all numbers, right? So for n being equal to any number. So what is this dot n?
Would it be multiplication, or is it different?
Let's take a look at it. So dot n equals 24 minus n. All right. What they're trying to do is they're trying to be really, really sneaky math people. And they're trying to trick you.
Okay.
Okay. How many of you have seen notation like this before?
I have,
you know,
but I don't remember.
Well, I mean, what I'm writing right now.
Like the dot with N,
Oh.
I remember it.
Oof, it's been a long time. But yeah.
It seems like the last algebra kind of stage before pre-cal.
Yeah. Let's say, or something like this.
So I believe those are read f of x equals x plus 1.
Mm-hmm. Yeah. Let's say. Really what they're doing is they're using this dot notation that they've just literally pulled out of thin air as a way of describing a function.
Oh.
So it's really just the same thing as notation like this. And they're just doing it because they're sneaky math people and they're trying to trick you.
But like literally, I mean, that dot is usually a multiplication symbol. How can they just?
That's what I said. That's what I thought it was like, oh, every time you
Yeah.
multiply n, maybe it equals that. I don't know.
It's fucked up.
Maybe because the dot is like larger than any other dot. That's why they think we would figure it out on our own.
So here's I'm gonna tell you a little bit of math trickery, a little bit of this kind of stuff. Math people just make up notation whenever they want. You know, this is what we call like fly speck notation, because it's like, oh well, this dot n is different from this, and oh wait, no, that's not a dot. Someone just sneezed on the page, and you know, this is math people do this. If you ever read like academic papers and things, you wind up in this kind of territory quite often. Fly speck. Yeah. So what we're going to do here, what they're saying is, okay, if we assume that this is a function, right? Let's say, let's take this dot n. Let's say that, let's just try playing around with it, okay? Let's say n equals 0, right? That's kind of like our base case, right? If n equals 0, what does dot n equal?
-24 minus n?
Equals 24 minus
N? Or 0?
0.
Okay.
Oh, 0.
Equal 24. Okay.
Okay, got it.
All right. How about if n equals 100? Then what does dot n?
100?
20. Yeah.
Oh, why?
It's 100.
If n is equal to 100, what does dot n equal? If we're
Oh,
substituting,
24 minus 100.
there we go.
Oh, okay. Whoops.
All right, and that's gonna get us what, 76?
Negative 76.
Right. Thank you. Okay. So now we know how this works, right? Let me. Oh, was that why I was making the line? There we go. What tool was I on before? Oh, I was on a brush. Oh, I see. That is a nicer line. Okay. Ooh, they have a calligraphy pen. Ooh, that's fancy. Okay, sorry. All right. So now we know how this dot n thing works, right? So let's look at our quantities again. Quantity A is dot n. And quantity B is n. Okay. So now they've thrown another wrench at us, right? They're not just saying dot n. They're saying n. They're saying dot n, right? What is dot n?
Again, probably you would have to now the dot has a value. No.
So I'm going to tell you another little math thing. You can treat functions just like other numbers. You can use a function itself as the argument to another function, just like a number. So do you remember ever doing like function composition back in high school? I'm going to go ahead and draw a little example over here. So let's say we have f of x equals x plus 1. And let's say we also had a g of x equals x minus 5. Why not? We could actually do a composition of functions. We can take one function and put it inside the other function. So we could do like, what's f of 0, right? And we can get what?
0 plus 1.
Right, which equals 1. But we could also take f and put in g of x as the argument. What would that get us? If we substituted g of x, if we use g of x as the input into the f function?
We would get maybe parentheses x minus 1, x minus 5 plus 1.
Right. Yes. I'm actually going to go
Close
ahead and
parentheses.
I'm going to make this a little simpler first. Yes, you are correct. But I'm going to do, all right, the brush. There we go. G of x plus 1, which, yes, you're correct, becomes x minus 5 plus 1, which equals x minus 4. Does everyone see how we did that?
Yes.
Yeah.
Okay. We could even do f of x like this. What does that get us? I'm going to go ahead and put a little vertical line here.
The x plus 1 plus x plus 1.
Yeah, x
Right.
plus 1 plus 1.
Right. So we get
Wouldn't
x
it
plus,
be x plus 1? Or does it have to?
what'd you say, Adeline?
Because f of x equals x plus 1. Wouldn't it be f of x plus 1?
I'm not sure I follow what you're saying.
On the top, you have f of x equals x plus 1.
Okay.
And so in your new equation, you have f of x. So wouldn't it be f of x plus x plus 1? Because f of x equals x plus 1.
We're substituting f of x for x. So in the same way, if you look at f of 0 here. Okay, so do you look back up here where we have right up here where we have f of 0. So we're throwing 0 into the equation, and so we substitute x with 0. The same thing. When we're substituting f of x for x, we're just swapping it in there. So this here was our x. Do you see how that happens?
I think I see it now. Thank you.
Okay. If you look here, it's a little bit. That's why I went with f of g of x first. It's a little easier to see that. Okay. G of x is the thing we're putting into this equation. And so x becomes g of x. So what's the, does that make sense?
Yes. Then you would have x plus 2.
Okay. Okay. Does everyone see how we did that? Because I know this is confusing because we're getting into the realm of, we're getting away from concrete numbers and we're getting into just letters and you know, stuff that makes math people really happy and just makes everyone else's brains hurt.
I think silence means go forward.
Okay, so the thing to keep in mind is that what they're doing with this dot notation is they're doing a function composition here. The same thing we did with this f of x, that's what they're doing with this dot n. If we treated dot n as like, you know, f of n equals 24 minus n. I'm writing out in a way that's a little bit more, hopefully a little bit more familiar from your algebra classes. Does this look a little bit more familiar?
Yes.
Okay. The dot n is exactly the same thing.
I still don't see how that's going to help us determine what's greater or not.
Okay. So what they want you to do is they want you to figure out what dot of n is. So,
well, we don't know.
But we can find it out using function composition. So who wants to take a stab at it?
Lee, go for it.
Yes, go.
Okay.
Daniela, you go for it.
Okay, so
not all the same hands now, class.
so dot of n. So we're going to start inside the parentheses and do 24 minus n, which is what the original dot means.
Well, if we're doing a dot something, doesn't matter what the thing in here is, right?
Right.
I'm just going to go ahead and put this as a question mark. That's going to get us
24 minus whatever it is.
Right.
Yeah.
So if we're going to put in dot n, that's going to get us what?
24 minus n.
Minus n? That's not what we put in as the, yeah.
Would it be dot n?
Isn't dot n equals 24 minus n? So inside the parentheses, inside the parentheses is 24 minus n, isn't it? Or no?
Right. Well, we've got dot n, right? And dot n, that expands to, if we expand the function, what does that become?
24 minus n. Right, so I was just putting it inside instead of outside the parentheses. But yeah, but you basically, inside the parentheses is now 24 minus n, and then outside the first dot is also 24 minus what was inside the parentheses.
Right.
So, okay. So 24 minus 24 is 0.
Mm-hmm. Right.
Minus
these,
10.
Yep. So these two cancel each other out, right?
Yeah.
Confusing. I'll do one with that. And then what are we left with?
negative n.
Well,
Or-
it's minus a negative n, right?
Oh, that 24 minus 24, but that minus still stays there, even
So
though
it's
the 24's cancel out. Okay, so
24
24
minus
minus
24
24 and also
plus
minus n.
right?
So we're left with n. So it's the same.
Yep. Okay, so dot n equals n.
So the two quantities are equal.
Yep. Okay. Does
was rough.
everyone see how this worked out? How this question worked?
Yes. If we wanted to look these questions over, like what kind of math is this? Like what if we wanted to look up examples of it, what's the name of this math?
This is called function composition. Okay.
Okay.
I'm gonna write it here. So the keyword.
And would you consider it like just as easy in this scenario to substitute a number for n just to, would that make it less confusing? Or I guess it would, like, if you could pick any number for n and it would still work out.
Let's see. So you're saying instead of going through and doing the like doing the function composition, just try and plug numbers in?
Well, instead of keeping n a variable, because we were told, b is n on its own, we could just pick, the number 10.
Right, but we kind of saw up here that, like, up here in the purple box I'm drawing, that with dot n, we were getting different answers, right?
Oh, true. Well,
So
yeah.
That's why we had to figure out what does dot n even mean, right? So we had to figure out what dot n was before we could even plug numbers into it.
Yeah, okay, fair enough.
But then once we determined what dot n was, it's pretty obvious, oh, the two are just equal.
Okay, and then at that point you've already answered the question and it would be a waste to keep going.
Right.
Okay.
But yeah, so again, the key word here is function composition. So the main concept is, can you take two functions and combine them and then be able to determine what the resulting function does? And I will tell you, this is actually something I use in computer programming quite often, like every day.
That's crazy.
Okay.
Such a joke.
I'm going to go ahead and save this as question 7. So I think question 8 is the one I'm going to skip over. So we're going to go to 9 next.
Will you be getting back to us with question 8?
Yes. I need a little bit more time to review that one. It is a pretty confusing relations question. Again, when I answered it, I actually did answer it correctly, but I'm not sure if I can really explain it well. I think that right now, if I tried to explain how I'm doing it, it would just be confusing. And like, it's like I was only really able to like half solve the question, then I just made an educated guess at the rest, which on the real GRE, you might have to do that a bit. But in the interest of giving you guys, really solid advice for now, I'm going to focus on the questions that I understand really well. So I'm going to skip question 9. or excuse me, question 8. 20 is for you. Yeah, okay. I promise I will come back to this one on our next meeting. Let me see. Yeah, I forget what it was, but we're just going to pass by this one. All right, so we're on question 10, excuse me, 9. All right, who wants to volunteer to read question 9?
Okay, I'll do it. It says a rectangular pole is 17 feet long and by 12 feet wide. The pole has a tile border of 2 feet wide on all sides. What is the area in square feet of the pole that excludes the tile border?
Okay. What's the question?
I believe we would need to use the border 2 feet wide in order to determine the other missing side, and then
Just what's the question?
Find the
what is the area
rectangle?
minus the border?
Okay, right. What is the area of the pool minus the border? What is the area of the pool without the tile border?
Do they give you any geometry equations like going into it, or do they just expect you to remember?
So this one is actually probably the simplest one that we've gone through so far. You're not going to need anything super special for this. This is just, can you draw this correctly? If you can draw this image correctly, you can solve the problem. There is a little bit of a gotcha to it, but you're not going to need anything super, any like niche geometry or trigonometry stuff in your mind for this. Everyone remembers what the area of a rectangular area is, right? A rectangular shape. If we have a rectangle of sides x and y, what's the area?
It's xy.
X times y, no?
Yeah.
Okay. Great. So if you know that, you can solve this problem. But it's not just as simple as, multiplying the width and height, right? Or the width and length. Because there's something more to it, right? So let's go ahead and start drawing our equation. So it tells us the pool is rectangular, right? One side is longer than the other. And what are our side lengths?
We have
17 and 12.
17.
Well, say that again.
Sorry, Adali.
It's
17
okay, go
and
ahead,
12.
take it
Patsy.
17 and 12.
Okay. So put 17 on the long side and 12 on the short side. So our answer is just 12 by 17, right? 12 times 17. We're off to the races. We're done.
No.
Okay. What's the gotcha here?
We have to subtract the 2 foot wide border.
Right. Okay. So it's saying that there's a border that goes all the way around this pool, right? So there's a little square that's 2 feet shorter on each side, right? So if we know that, and we know that that's 2 feet, that's 2 feet, 2 feet, 2 feet, like that. And it's going all the way around the pool, right? So this in here, you know what? It's probably appropriate if I use blue. So this is what they want us to find, right?
Would we have to subtract then the 2 from the 12 and the 17?
Okay. Let's try that. So what would our area equation be?
So then it would change the 12 to a 10, and then the 17 to a 15, leaving us with A equals 12 times, what's it called? 12 times 15?
I see what the gotcha is now.
What is it, Lee? What is it?
Lee's on to something. But I'm going to keep going, though.
Or am I kind of have to do the area? Would it matter? Does it matter if it's an area or if I'm just subtracting the feet?
What do you mean?
Well, because I could, we could also go the very long route, which is where my mind went at the beginning of getting the area of the entire circle. I'm sorry, rectangle as a whole, and then getting the area of the smaller thing, and then subtract them.
Well, the answer that the question's asking for is the area of the smaller thing, right?
Well, yeah, but in order to know it, then we need to know both areas, correct? No?
No, I mean,
or the easy step would be just the minus 2.
Okay, so I mean, what you said is, you've come up with, you subtracted 2 from 12 and 2 from 17. So therefore, what you're saying is the answer to the inside would be 10 times 15 equals 150. Is that your answer?
Yes.
Okay. So that is one of the answers on the quiz.
I know, but that's the easy route. The other longer one that I was explaining, I think that's the correct one.
Not quite.
Okay, tell me.
You are correct that something is wrong with this. We got here a little too easy.
So it's not that easy. That's the answer right here.
Okay. So I think Lee has a bit of a hint as to what's going on here. What do we do wrong?
So what actually drawing out this image makes it really clear, but because you put these 2 foot borders on each side of
because it's a border that goes around the entire pool, right?
Yeah, each side of each side. So you're actually not subtracting 2 from each side. You're actually subtracting 4 from each side.
Yes, that's what we did wrong. It's not 12 minus 2. It's actually 12 minus 4 because the border's on both sides. So what's that get us? 8, right?
I don't get it.
Okay.
So yeah, I got it from looking at the diagram. If you look at the right side of the diagram, and you've got 12 is the total length, and then you need to get the interior rectangle. You've got a 2 foot border on the top and a 2 foot border on the bottom.
Okay, I see.
That's what you need to get into the inside rectangle, and same thing on the top.
Right.
So
because there's
2
4
borders,
corners, not just one. Okay.
Okay. So let's take a look at this. So if we've got 2 here and 2 here, then what's left for the orange here, for this orange side?
Eight, right? Wouldn't that be 8?
Yep.
Yeah.
2 8 and 2, that's 12, right? And same for here. What would be the length of our purple side?
13.
Yes. 17 minus 4. So that gives you 13. Right?
I still don't get why we have 2 of the number 2s.
Okay, so it's saying this is a pool, right? This is a swimming pool. Let me draw a picture that's a little bit more descriptive. And this swimming pool, so this is the pool, but it has a tile border going around it. So here's the water in the swimming pool, right? Okay, and of course, like any good swimming pool, it's got, you know, a nice little rubber duck in it. You know, maybe a little beach ball.
I was like, what?
Okay. Okay. Okay.
No.
Okay. But the important part is it has a tile border going around it. So let's say there's this, you know, nice little tile border. Let me use a nice gray tile.
You.
So here's this.
So, okay, so that's still an aerial view.
Right. So there's this tile border
Sorry,
going
Lee.
around the swimming pool. So I like drawing pictures. It helps me figure these problems out. But the deal is they want to know what the size of the swimming pool is, right? They don't want the tile border. So they're just telling us, they're just asking for us, what's the area of the swimming pool, not the area of the tile.
I get that. The only thing that I don't get is why we have 2 2s.
Okay. That's because the tile border is 2 feet wide, right?
Okay.
So it's 2 feet wide here, and it's 2 feet wide here. So, and it's 2 feet wide here and 2 feet wide here. So they told us the length of the tile, right?
Can you use colors and you just like use colors to show me from this side to this side is 2 and from this side to this side is 2. The other 2s that you have on the other pool, you're going sideways. I think that's what's throwing me off. I don't know where you're getting the 2 repetitive numbers from.
The 2 2s?
Yes, where are you getting them from?
Okay. So they are telling us that the pool has a tile border 2 feet wide, right?
Yes.
Okay. And what they've told us is the length of the pool with the border, right?
Yes.
Okay. So they're telling us that, like, you know, this whole thing is 12 feet wide, right?
Yes.
Let me use the brush.
Sorry, guys.
No, it's
Maybe
cool.
I'll take
It's cool.
a side little lesson on where
It's
the 2s are
cool.
coming from.
No, it's cool. So the whole pool with the tile border is 12 feet wide.
It's cool. I went downstairs to make a sandwich.
I'm sorry. Yes, I get all of it. I just need to know where the 2s are coming from. If you could just highlight with green where the 2s are coming from,
Okay.
that will solve my issue.
It's
Okay.
on each side, Adeline. So you have to account for the 2 on both sides because it's surrounding the pool.
So it's not just one side, it's saying the whole thing.
Right.
Yeah.
So you get that where I just draw this right here, that's 2 feet and 2 feet, right? For 2 feet height and 2 feet in the width, right?
Yes.
Well, the same thing on the bottom. We have 2 here and 2 here. And lengthwise, you know, we've got.
I think for now we should move on because I have more questions and it's wasting the time. So just
No,
move on to
it's not wasting time.
It is because I just there's so many questions in my mind right now about those two. I think
Continue.
yeah, no, just move.
No. It's total. The total, because the border is going around all 4 sides of the pool.
No, I get the concept. I mean, I understand it. I just don't fully, like, I am not accepting your answer. Just move on for now.
No. Just.
Move on.
Just, let me
I'll ask you later. I have you here.
No. Just wait. Okay, look. The tile border. It extends 2 feet to the left and 2 feet to the right. Okay? Do you see that it's doing that? It's 2 feet here and 2 feet here. So you have to take both of those out. Okay. And then same for the 17. So this whole thing is 17. That's the width of the pool with the tile. But we're taking out this part and this part. And each of those is 2. Same for here. That's 2 and that's 2. In other words, we're just trying to measure this part here. Okay. Okay. Feeling better, Adelaide?
Yes, I get it.
Okay. I'm very proud of you.
Sorry, guys.
Okay. Everyone back?
We here.
Okay.
Yes.
So we've got a. All right. Okay. I'm going to go ahead and make a little separation here. Okay. So back to our question. So we've got 12 minus 4 and 14 minus 4 for the actual sides, right? So now how do we find the area of the pool?
It's 8.
Multiply them.
Sorry, say that again?
Multiply 8 times 13, which is 104.
Fantastic.
Congratulations, you guys.
All right. And I'll just go ahead and add into here 8 and 13. Times 13. All right, great job, everyone. Was there anything about this question that threw people off?
We shall never talk about it again.
Oh.
You and I will, but not with the group.
Oh.
101 tutoring time.
No, seriously.
Helping you, Adelaide, helps us explain it so we understand it better, I feel. So it's good when people don't always get it right away, because then we get to elaborate and understand it more ourselves. So I feel it's a good thing.
Trust me,
You know, I think-
everyone is going to have their moment with these kind of questions.
I think what it was is that my mind just wasn't accepting the fact that you were only taking the corners out when it's the entire border.
Mhm.
When you drew the lines across to mimic the size of the other pole, then I understand why you're only taking the corners out, which is, it still doesn't make sense in my brain that you're not just taking out the entire gray area out and that you're only taking out the corners. But for now, I'm just going to accept it as
Well,
is.
to find the size of the actual water area, the actual pool, that's all we're doing. We're like, I'm literally taking those whole sections away. Like, I'm taking the entire tile border away.
Okay. Again, 101 session later. For now, let's
Okay.
just move on forward.
All right. We've got a little bit of time left. I'm going to try and get to the last question. I have to be off of, unfortunately, I have to leave at noon, but I think we have enough time to get through the last question, question 10.
I will refrain my opinion from the last question, guys.
Oh, we got this. It's okay.
Okay, I'm going to go ahead and make up number 10. All right. Here we go. Okay, who wants to read the question?
I'll read
I'll
it.
read it. Oh, Golly, go.
No, go ahead.
Oh, I've read a lot.
Okay. Doris and Edward both collect stamps. Nerds. Just kidding. If Doris gives Edward 72 stamps, then Doris will have 4 times the number of stamps that Edward has. If Doris gives Edward 129 stamps, then Doris will have 3 times the number of stamps that Edward has. How many more stamps than Edward does Doris now have? Before she gives him any, I'm assuming.
Right. How
Oh
many
my
more stamps
God.
than Edward does Doris now have? So this is a pretty confusing question, but at least they've kind of spelled out what the question is, right? So what is our question?
How many stamps do they each have right now? Or
Well,
how many?
specifically,
No, how many more stamps than Edward does Doris? How many more stamps does Doris have than Edward?
right.
We already know Doris has more stamps in general.
Right. How many more stamps than Edward does Doris have? So it's not asking how many stamps does Doris have. It's asking how many more than Edward she has. How she wants to really rub in Edward's face how many more stamps she has, right? Because that's just what stamp collectors do, right? That's what stamp nerds do. Is they just rub in each other's face how many more stamps they have than other people, right? Okay.
I wouldn't know.
So here's the thing: they're not actually telling us any real concrete numbers, right? Because they're math people, so they're giving us weird relations. What's the first relation?
72, and then Doris has 4 times more than that.
Okay, it's saying if Doris gives Edward 72 stamps, then Doris will have 4 times the number of stamps that Edward has. What does that even mean, right? Okay, who wants to help me write this out? We can write out an equation here.
Okay, so if we can create like a variable for what they have now, which is like D for Doris, E for Edward.
Okay,
Like
that's a good idea. So
D
equals
how many
Doris's,
stamps?
yeah,
Yeah.
Doris's stamps, right?
Yeah.
And E equals Edward's stamps.
Yeah.
Okay, that's a great starting point. Using that, let's try and write out this first relationship here. If Doris gives Edward 72 stamps, then Doris will have 4 times the number of stamps that Edward has. So how would we say Doris giving Edward 72 stamps in a math way?
You could either do D minus 72 or E plus 72.
D minus 72 and E plus 72. Right. So if we do this, if we take 72 of Doris's stamps and give them to Edward's, then what's the total? Then what does the relationship equal?
4 times?
Yeah, it's saying if we do that, then Doris will have what?
4 times more?
Right. Okay. So if we do this, then
And that would only be for D though, right?
well, this is the math way of writing what they just said. We're saying we're taking 72 of Doris's stamps and giving them to Edward, and if we do that, then what we're left with is, if we do this, then Doris will have 4 times the number of stamps that Edward has.
Got it.
In other words, it's saying Doris equals 4 times the amount Edward has, but not their current values. It's not saying their current values are that. It's saying only if we take away, or rather we give 72 of Doris's stamps over to Edward. This four times relationship is only true if we take 72 of Doris's stamps and give them to Edward. This is tricky, I know. What's the other relationship?
So then it would be D minus 129 equals 3 times E plus 129.
Great, okay. So I'm going to write this over here. Can you say that one more time?
So D minus 129 equals 3 parentheses E plus 129.
Great, okay. Does everyone see why that is? How this second relationship works out?
Yes.
Yeah.
Got it.
Okay. I'm going to go ahead and get rid of this bit here. Okay. So knowing this, what should we do next?
Do we need to solve for the variables?
Okay. Yeah, that sounds like a great way to go. So, let's do that. Let's pick one of them. Let's pick this one, how about? And let's see, should we solve for D or E?
D.
Okay. D is probably going to be easier because all we have to do is just bring the 72 over, right? Okay. So D equals 4 times E plus 72. plus, right? Is this plus or minus?
Plus.
Plus.
Right, because we're adding 72 to both sides, right? Okay, I'll be completely honest with you guys. When I did this on my own, I accidentally made it minus 72. And I got the wrong answer. And I had to go back and do it over and found, oh man, I just did a stupid, sign flipping error. Okay. D equals 4e plus, what's 4 times 72?
88.
Say that again, please.
288.
288. Okay. All right. 4e plus, say that again, please. 360?
Yes, 360.
Okay. So there we go. D equals 4e plus 360. All right. Let's try and do the same thing over here on the second equation. I'm going to just go a little line there. So
Friendly reminder, you have like about 3 minutes
Yep,
before you
I
have
know.
to disconnect.
that's why I'm trying to go through this kind of quick. So e plus 129 plus or minus 129?
Plus 129.
Okay, plus 129. You guys can help me with the math here, right? 3e plus
It's 387.
387? Okay.
129 times 3. Yeah, plus another 129 is 516.
516. Okay, great. So D equals 3e plus 516. So now we've got D equals this and D equals this. What's our next step?
You just combine those two equations. Like
Right, okay.
Take away D.
Okay, so let's do it. So if we set this D equal to this D, we can get 4e plus 360 equals 3e plus 516, right?
Yes.
Okay.
Mm-hmm.
If we subtract 3e from both sides, we get e plus 360 equals 516. Who wants to do the math here? E, subtract 360 from both sides. 156 says, that's what it says. Okay. All right. So we have E now. How do we find D?
Plug it into either one of those equations.
All right, let's do it. D equals 4, 156
The alacrity.
plus 360. What do we get? What's 4 times 156?
624.
624.
624. All right. Total, what do we get?
984.
984. Okay. And now, what's the last thing we need to do?
Subtract
D
Edwards
minus
stance.
E equals 984 minus 156. What do we get?
828.
828. There we go.
It's a lot of stamps.
Boom.
That's a lot of stamps. Yes.
All right, guys. I'm
Totally.
going to have to call it there. But yeah, we finished question 10.
Yay, thank you.
Thank you.
Submit. Are you able to submit it? What would be the?
Yeah. Boom. So yeah, there we go. And
Wow.
I will send you guys all of the write-ups we did, all the little pages, all the drawings, and the recordings. But I've got to step out now because I've got a interview calling in a few minutes, and I.
Good luck.
Yeah. Okay.
Good luck.
Thank you guys. I will join with you guys again. When's our next meeting? Next week?
This
Monday.
week on Monday. Yeah,
Monday.
Monday, 10:15. You guys.
All right,
Woo,
guys.
see you guys there.
I'll try to work in my shapes during the weekend.
So, create a little cheat sheet.
All right.
Yeah. Study hard. Bye.
All
Bye,
right. Peace out, guys.
Take care. Have a
Cheers.
good day.
Thank you.
Stop sharing.